Welcome to Chemistry Simplified. The topic for today is weak acids. Let's say we're given HA as a weak acid. If it was to dissolve in water, it would ionize partially, slightly, right? The small arrow tells us that this reaction is not moving forward much. So it would produce H3O plus, which is hydronium ion, plus A minus, which would be the conjugate base. Now look carefully, this reaction will be going back, meaning that the reverse reaction is favored. If we were to dissolve a weak acid in solution, most of what we would find in the solution at the end of the reaction would be HA, the weak acid, because weak acid do not dissociate much in solution. That's what we just said. So HA as a weak acid does not dissociate or ionize much in solution. At the end of the reaction, mostly HA, the weak acid, would be found in solution because it does not dissociate. Weak acid are also weak electrolytes. On the other hand, weak acids have strong conjugate bases, meaning that A minus is a very strong conjugate base because it's from a weak acid, in this case HA. And the reverse reaction is favored, meaning that we'll find more reactant in solution than product. And lastly, any acid that is not strong is considered to be weak. For example, in our last presentation, when we had talked about the strong acid, we mentioned there were mainly 6 strong acids: hydroiodic acid, hydrobromic acid, hydrochloric acid, perchloric acid, sulfuric acid. Let's look at a couple examples. Let's look at the first one. So let's say we're given hydrofluoric acid. So this is a weak acid. If we would react with water, it would ionize only partially in a small quantity to produce fluoride ion, which would be its conjugate base. We know this would be a strong conjugate base because it's from a weak acid, plus hydronium ion. And the reverse reaction would be favored because it's a weak acid. So hydrofluoric acid would dissociate only slightly in solution. At the end of the reaction, mainly hydrofluoric acid would be left in the solution because it does not ionize much. And fluoride ion is a strong conjugate base because it's from a weak acid. Example number 2. Acetic acid is a weak acid. If it was to dissolve in water, it would ionize only slightly to produce acetate ion, which is the conjugate base, which would be considered to be strong because it's from a weak acid, and hydronium ion. And we said the reverse reaction is favored. So acetic acid is a weak acid, so therefore it dissociates only slightly in solution. At the end of the reaction, mostly acetic acid would be left. And acetate ion is a strong conjugate base because it's from a weak acid. Alright, this is our presentation for today. Please remember to like, subscribe, and share, and let us know if you found it to be useful in the comment section. Thank you.